This lecture is about link analysis for web search. In this lecture, we're going to talk about web search, and particularly focusing on how to do link analysis and use the results to improve search. The main topic of this lecture is to look at the ranking algorithms for web search. In the previous lecture, we talked about how to create index. Now that we have got the index, we want to see how we can improve ranking of pages on the web. Now, standard IR models can be also applied here. In fact, they are important building blocks for supporting web search, but they aren't sufficient, and mainly for the following reasons. First, on the web, we tend to have very different information needs. For example, people might search for a web page or entry page, and this is different from the traditional library search, where people are primarily interested in collecting literature information. So this kind of queries are often called navigational queries. The purpose is to navigate into a particular targeted page. So for such queries, we might benefit from using link information. Secondly, documents have additional information. And on the web pages are well formatted. There are a lot of other clues, such as the layout, the title, or link information again. So this has provided the opportunity to use extra context information of a document to improve scoring. And finally, information quality varies a lot. So that means we have to consider many factors to improve the ranking algorithm. This would give us a more robust way to rank the pages, making it harder for any spammer to just manipulate one signal to improve the ranking of a page. So as a result, people have made a number of major extensions to the ranking algorithms. One line is to exploit links to improve scoring. And that's the main topic of this lecture. People have also proposed algorithms to exploit the large-scale implicit feedback information in the form of click-throughs. And that's, of course, in the category of feedback techniques. And machine learning is often used there. In general, in web search, the ranking algorithms are based on machine learning algorithms to combine all kinds of features. And many of them are based on the standard retrieval models, such as BM25, that we talked about, or query likelihood, to score different parts of documents, or to provide additional features based on content matching. But link information is also very useful, so they provide additional scoring signals. So let's look at links in more detail on the web. So this is a snapshot of some part of the web, let's say. So we can see there are many links that link different pages together. And in this case, you can also look at the center here. There is a description of a link that's pointing to the document on the right side. Now, this description text is called anchor text. Now, if you think about this text, it's actually quite useful, because it provides some extra description of that page being pointed to. So for example, if someone wants to bookmark Amazon.com front page, the person might say the biggest online bookstore, and then with a link to Amazon, right? So the description here actually is very similar to what a user would type in the query box when they are looking for such a page. And that's why it's very useful for ranking pages. Suppose someone types in the query like online bookstore or biggest online bookstore, right? The query would match this anchor text in the page here, and then this actually provides evidence for matching the page that's being pointed to. That is the Amazon entry page. So if you match the anchor text that describes a link to a page, actually that provides good evidence for the relevance of the page being pointed to. So anchor text is very useful. If you look at the bottom part of this picture, you can also see there are some patterns of links, and these links might indicate the utility of a document. So for example, on the right side, you can see this page has received many in links. Now that means many other pages are pointing to this page. And this shows that this page is quite useful. On the left side, you can see this is another page that points to many other pages. So this is a directory page that would allow you to actually see a lot of other pages. So we can call the first case authority page and the second case help page. This means the link information can help in two ways. One is to provide extra text for matching, and the other is to provide some additional scores for the web pages to characterize how likely a page is a help, how likely a page is an authority. So people then, of course, proposed ideas to leverage this link information. Google's PageRank, which was the main technique that they used in early days, is a good example, and that is an algorithm to capture page popularity, basically to score authority. So the intuitions here are links are just like citations in the literature. Think about one page pointing to another page. This is very similar to one paper citing another paper. So of course, then if a page is cited often, then we can assume this page to be more useful in general, right? So that's a very good intuition. Now, PageRank is essentially to take advantage of this intuition to implement it with a principled approach. Intuitively, it's essentially doing citation counting or in-link counting. It just improves this simple idea in two ways. One is it would consider indirect citations. So that means you don't just look at the how many in-links you have. You also look at the what are those pages that are pointing to you. If those pages themselves have a lot of in-links, well, that means a lot. In some sense, you'll get some credit from that. But if those pages that are pointing to you are not being pointed to by other pages, they themselves don't have many in-links, then, well, you don't get that much credit. So that's the idea of getting indirect citation. Right, so you can also understand this idea by looking at, again, the research papers. If you're cited by, let's say, 10 papers, and those 10 papers are just workshop papers and that are, or some papers that are not very influential, right? So although you get 10 in-links, and that's not as good as if you are cited by 10 papers that themselves have attracted a lot of other citations. Right? So this is a case where we would like to consider indirect links, and PageRank does that. The other idea is it's going to smooth the citations, or assume that basically every page is having a non-zero pseudo citation count. Essentially, you're trying to imagine there are many virtual links that would link all the pages together, so that you actually get pseudo citations from everyone. Now, the reason why they want to do that is this would allow them to solve the problem elegantly with linear algebra technique. So I think maybe the best way to understand the PageRank is to think of this as to compute the probability of a random surfer visiting every web page.